Welcome to today's statistics lecture on uniform distribution.
Okay, so let's go ahead and look at the uniform distribution. The notation for uniform distribution is going to be the random variable x, the squiggly line u, and then it's going to give you the starting and ending point of A and B. Now the formulas for a uniform distribution, you're going to have your f of x, which is going to be 1 over b minus a. So that's just the end point and the starting point. When you have a uniform distribution, they're going to give you a starting point A and an ending point B. And then your f of x, this is going to be 1 over b minus a right here. The line of your curve for all of these graphs is your PDF. And that's your probability density function. And the area under the curve for all of these is called your CDF, which is your cumulative distribution function. And this is where it's going to give your probability is going to equal to the area under the curve. So when we're figuring out area, it's always going to be what's under the curve. And if it's the area, if it's the total area, that's always going to equal to 1. And then if it's a portion of the area, it's going to be between 0 and 1 because it's going to be a percentage of the total. So the formulas, once again, for the uniform distribution are your f of x, which is your probability density function, is going to be 1 over b over a. Mu, which is your mean, is going to be a plus b divided by 2. And this is your theoretical mean. It's important to recognize, so this is called your theoretical mean. And if you'll remember, we've had several different definitions of mean. You've got your sample mean, your population mean, and then now you also have your theoretical mean. So whenever they ask for the mean, you want to pay attention to what type, what they're giving as the label for mean, so that you know which formula that you're going to be using. Your standard deviation, this is also the theoretical standard deviation. The formula is going to be the square root of the square of b minus a squared divided by 12. And then when we write the probabilities for the uniform, we're going to write that as probability of a less than x less than b is how we would write the probability. And the probability of the inequalities is also going to equal to the probability of a equal to x less than or equal to b, because the probabilities are going to be the area under the line. And so it's still going to be, the same space. So whether it is, it includes those endpoints or not, the area is going to be the same. If it includes them, then it's going to be called inclusive. And if it doesn't include them, it's going to be called exclusive. And the probability is found is equal to the area of points A to B, and that's just going to be the base times the height, because we have a rectangle. So that's going to equal, your base is going to be your larger number B minus the smaller number A, multiplied by the height, which is your probability function. So that's 1 over B minus A. And as you can see, if we're doing the whole graph, that's going to all equal to be 1. Okay, any questions so far? Okay, so that's what the formulas are going to look like when we're just using the variables. So now let's look at it if we actually plug in some numbers. So let's give the uniform probability distribution for X, uniform distribution of points 0 to 20. Okay, then my f of x is going to equal 1 over 20 minus 0, which is just going to be 1 over 20. My theoretical mean is going to be 0 plus 20 divided by 2, which is going to give me 10. And my standard deviation is going to be 20 minus 0 squared divided by 12. And I'm looking on my notes, and okay, so that's just going to give you 20 squared, which is 400, divided by 12. So that's going to give you the square root of 400 divided by 12, which is equal to the square root of 33.3, which is going to give you standard deviation of 5.77, and we'll just round that up to 5.8. Okay. And then the probability of 0 between 0, x is greater than 0 and less than 20. That is just going to be 20 minus 0 times 1 over 20 minus 0, which gives us 1, which is what we would expect. Okay, any questions? So that's what it would look like for the uniform distribution if I plug in the numbers for A and B. Any questions? Okay. So now let's say that we have the same A and B. So we'll go ahead and keep our A and B as 0 and 20. But this time we want to find, oh, let's see, and I didn't do the graph. So let me just take a step back and do the graph. So the graph is just going to be from point 0 to 20. This is going to be 1 over 20. And then the area is going to be everything that's shaded. So that's what my graph would look like. This is x, and this is f of x. Now let's say that they're going to give me the same range of with minimum and maximum A and B at 0 and 20. But this time I want to find a portion of that graph. Find out what the probability is of X being between 4 and 15. Okay, so for that, my graph, I'm still going to have the same A and B points, and my f of x is going to stay the same. But now I'm looking for the area between 14 and 15. So I'm just looking for a smaller area. So remember, I've got my probability is going to equal the area of between 4 and 15. So that means my base is going to be 15 minus 4, but my height is still the line of, so I have a smaller base, but my height is still that same line. So that my height is still going to be the 1 over 20. So that's going to give me 11 over 20, which equals 0.55. So that tells me that the probability of X being between 4 and 15 is going to be 0.55, which is the same as 55%. Okay, any questions? Okay, so these are the formulas for finding the uniform distribution. Now there's one more point, and with a uniform distribution, so remember it's the area under the, the shaded area under the line. So let's say if I was given P equals 15, so this would be, I have my 20 here, so we're looking at just number 15, just a single point is a line. Well, if I have, if X equals 15, then that's just a straight line, and the width equals 0. So when I go to solve the area of 15, my width is going to be 0 times the height 120, which is just going to be 0. So that tells me that the probability for getting any individual number is going to equal to 0. Okay, so you want to remember that when they're asking you, so they're looking for probability, or what's the probability that a value is going to fall within a certain range of numbers. It's always going to be the area under the curve from those range of numbers. But if they just give you a single number, there's no width, so there's no, you can't measure the probability. The probability is just going to be 0 that you get exactly that one number. Okay, any questions? Back to the uniform. and we're going to solve for the 90th percentile. So once again, let's find the 90th percentile. So let's go back here. So we're looking for so this is going to be the probability that x is less than k, and we're going to set it equal to 0.90 for the 90th percentile. So once again, we're going to do the base times the height. So let's use what we had before, where we had the 0 to the 20 as our A and B points. And then we're going to solve for k. So that means when I'm solving for the probability, it's going to be the base times the height. So that's going to be k minus 0 times the height, which would be 1 over 20. And we're going to set that equal to 90 because we know what the percentile is. And then we're just solving for k. So that's going to give me k over 20 equals 0.90. And then take 20 times 0.90 is going to give me k. So that would tell me this point, my k is going to be 18. Good job, got 18. Okay? Any questions? So then when you're finding your quartiles, once again, it's going to be the same thing. If I wanted to find the IQR, I'm going to do the same thing. I'm going to make that P x less than Q1 equals 0.25, and your P of x less than Q3 is going to equal 0.75, and then you're going to subtract those. Because I think there were some questions that asked for that range. Okay, so that's what you would use for your uniform distribution.
Thanks for watching. Be sure to check out the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos by Caz Academy. Thanks for watching. We'll see you at the next video.